Here we have a working implementation of the Sonar device built on top of an Arduino Uno board. The additional sensor we have here is an ultrasonic sensor, an HC-SR04 module, which can be purchased online as an add-on for the Arduino. This serves as the device that we are using in order to measure the distance we are from a particular object. We also have a beeping device which signifies if we are getting closer and closer to an object or moving further away, which correlates with the frequency of the beeps and also the timing of the LED on the Arduino board, which matches the beeping. As you can see, the beeping frequency increases the closer you are to a particular object. Additionally, the data we are receiving from the ultrasonic sensor, which, as a result of sending out sound waves, waiting for them to propagate back from a collision with an object, and then measuring the difference we have, we are able to take an exact measurement we have of the distance just by doing a simple calculation. By taking into account the speed of sound per microsecond, we can use that to our advantage and multiply in order to compare the frequencies we are receiving back from the sound waves that we sent out. Additionally, the data is sent back to the Arduino IDE interface, and over there we can see the exact distance as a digital value. The devices required to complete this project are, as can be seen here, we have the Arduino Uno board and we have the breadboard attached to it. I've already done some attached some jumping cables here. However, I will explain those further. Here we have the HC-SR04 sensor, which is what we use to measure the distance. It is the ultrasonic sensor. And here we have the beeping device, which comes with the Arduino kit. The first thing we need to do is set up the jumper cables. In this case, I've already set it up. However, in order to give a clearer indication, we look here first at the sensor. Here we have four pins attached to it, and on each of the pins there is a label that indicates which part of the Arduino board it should be connected to. We have the first thing here, VCC, trig, echo, and then ground. The VCC and ground, as would be expected, we have ground attached to the ground connector on the Arduino board, and then the VCC is connected to the 5-volt pin on the Arduino board. The other two pins relate to the data that is being sent and received. The trigger is the data that is being sent out, how that is influencing, and the echo is what we are receiving back when the sound waves are propagated. The first thing we need to do once we have this set up is, in this exact order, we have the cables attached. So the ground and the voltage, those are the first and the last pins, and in this example we're putting it from the 30 to the 27 in the F column. Now, in addition, there are two other cables here, the yellow ones that I have attached, and these are connected to two pins on the Arduino board, which we'll be using to send and receive data. In this example, we have set it to pin 10 and pin 9. It doesn't make a big difference as long as it is consistent with the code, which we will see later on. Now, secondly, having the beeping device. In order to attach this, we have one cable attached to pin 8, and this, it doesn't matter exactly which order you put this in. There are two pins here, and we have the other side of the cable attached to ground. And here we have our basic setup completed. Additionally, of course, you will require USB, and another modification that can be made for this project is to use something like a battery pack or an external battery charger. And in that case, once you have the code compiled and downloaded and uploaded onto the Arduino board, you can simply detach it from a PC and use it as a portable device via using a battery pack and attaching it to the USB. So in this case, if we plug it in, we'll see the Arduino board beginning to light up. Now, as I already completed the coding for this and uploaded it, it immediately goes back to the state it was in previously. Now, in order to clarify, there are two additional jumper cables here, and the job of these is simply in order to connect these two. So here we have the ground and the 5 volt connected to the first two columns in the plus and minus label. Now this goes to the exact corresponding parts on the sensor where we have the ground and the VCC, and so you must ensure that these are matching correctly.
Interesting component of the entire system we have set up here is this visualization that goes with the distance we are from a particular object. It is like similar to a graph where on the vertical axis we have the distance, and on the horizontal axis we have time. For example, if we were to move further away, we see that the values in the graph are increasing, and this visualization is continuous in line with the data that's coming in from the Arduino interface. The sensor supports up to 4 meters in distance as the distance rating, and therefore it is able to take accurate measurements from between less than 10 centimeters up till 4 meters. Here we see moving further and further away. This also allows us to see the rating that we are reaching in terms of how far we are from the limit of the sensor, which is 4 meters. In this case, we can assume that we are almost around 2 meters away from the object we are measuring. So in this case, if we were to go into the Arduino IDE, you go into Tools and down to the serial monitor. As a note, this cannot be running at the same time as the processing application, which we are using to show the visualization. However, if you look here, we are able to see the distance. As of now, this is 22 centimeters away from the wall. Let's move further away. You'll see the values beginning to change. 26, jumping to 63, and so on. Now if we move back, again, we have the same situation. Therefore, we can see that this is actually quite an accurate device for measuring distance. The code for this particular setup is available on my GitHub page, which I will link below. However, just taking a brief look, as an overview, we are required to use two applications here. One is the Arduino IDE interface that codes the Arduino board and provides us with the data. And then there's a second application, which is called the controller application, which is necessary in order to build the visualization. So the processing application is also compatible with Arduino and is built. It can be found online for free as well. And simply what it does is takes the serial data input that we're receiving from the board as of this moment, and we perform simple calculations on it, and then using that we are then able to code however type of visualization we require. In this case, I built certain objects as squares, which I then combined with the data that we're receiving, and using a linear graph of time and distance, it simply updates continuously as we saw earlier. So if I was to run this again, here we see the visualization again. Moving further away, it increases. Moving closer. I'll also link to the code for the visualization in the comments below, in case anyone wants to have a look at that, which will also be up on my GitHub page. On that note, guys, I hope you enjoyed this tutorial. Here we have our working Sonar device, which you can build at any time at your home. The sensor, by the way, which I didn't mention earlier, can be bought from Amazon or other places online. My particular model that I got here was from Amazon and it cost me $12. However, there are cheaper versions available from other websites which have the same functionality. Thank you for watching.